and welcome to Alpha Omega General Training videos. In this tutorial, we will be learning about moving mesh and MRF modeling using ANSYS Fluent. ANSYS Fluent is a powerful computational fluid dynamics tool that provides advanced capabilities for moving mesh and MRF modeling. Whether you are a skilled student, researcher, or engineer, this tutorial will assist in enhancing your expertise in this field. So, let us begin exploring the intriguing realm of moving mesh and MRF modeling. The moving mesh and multiple reference frame models in ANSYS Fluent are used to simulate fluid flow in rotating machinery or in any system where fluid flow is affected by moving boundaries. The moving mesh model allows the mesh to deform and move according to the motion of the boundary. This is useful in simulations where the boundary's motion directly influences the fluid flow, such as in the case of a piston moving inside a cylinder. The MRF model, on the other hand, is a steady-state approximation technique used to simulate the effect of rotation. In this model, the computational domain is divided into stationary and rotating zones. The rotating zone contains the rotating parts and the fluid within it, while the stationary zone contains the rest of the domain. The MRF model then solves the Navier-Stokes equations separately in these zones, considering the relative motion between them. Both models are powerful tools in ANSYS Fluent that allow engineers and researchers to accurately simulate complex fluid dynamics scenarios. The moving mesh and multiple reference frame models of ANSYS Fluent are critical tools in the automotive industry. The moving mesh model is used to simulate dynamic mesh motion and deformation. It's particularly useful in automotive applications where there's a need to simulate the movement of components such as the opening and closing of valves in an internal combustion engine or the movement of pistons. On the other hand, the MRF model is used to simulate the effects of rotating machinery without the need for a dynamic mesh. This is important in scenarios where the rotation of components like wheels, gears, and turbines need to be analyzed. Together, these models enable automotive engineers to accurately simulate and analyze the performance of various components and systems in vehicles, leading to better design and optimization. This can result in improved fuel efficiency, reduced emissions, and enhanced vehicle performance. By providing accurate and efficient simulation capabilities, ANSYS Fluent moving mesh and MRF models are invaluable tools in the automotive industry. The moving mesh and MRF models are extensively used in the aerospace industry to simulate and analyze complex fluid dynamics problems. The moving mesh model is particularly useful in simulating problems where the geometry changes with time, such as the deployment of landing gears and control surfaces on an aircraft. This model dynamically adjusts the mesh to accurately capture the fluid flow as the geometry changes, enabling engineers to predict and optimize the aerodynamic performance of these components. On the other hand, the MRF model is used to simulate rotating machinery, such as the turbines and compressors in a jet engine. By defining a rotating reference frame around these components, the MRF model allows engineers to simulate the complex fluid and heat transfer phenomena that occur in these machines, helping to improve their efficiency and reliability. In summary, these models provide crucial insights that enable aerospace engineers to design safer, more efficient aircraft and spacecraft. Both of these models are also widely used in the energy industry. Mesh motion is extensively utilized in modeling rotating machinery such as wind turbines and gas turbines. It allows the simulation of the interaction between rotating and static parts, providing accurate predictions of performance and identifying potential issues. On the other hand, the MRF model is a simplified, steady state model used for simulating rotating parts. It's often applied in the design and analysis of pumps, fans, compressors, and other turbomachinery. MRF model can help in predicting the performance of these machines under various operating conditions. These models help in optimizing designs, improving efficiency, and reducing energy consumption, which are critical aspects in the energy industry. They also assist in understanding and mitigating problems related to vibration, noise, and wear, leading to improved reliability and lifespan of equipment. Thus, ANSYS Fluent's mesh motion and MRF models play a significant role in the design, analysis, and optimization of rotating machinery in the energy industry. ANSYS Fluent's mesh motion and multiple reference frame models are advanced simulation techniques used to model rotating machinery or moving parts in a fluid domain. The mesh motion model allows for the actual physical motion of the grid points in the computational domain. This model is highly suited for applications where the geometry changes over time, such as piston motion in an internal combustion engine or a turbine blades rotating. This model requires a significant computational cost due to the need to constantly update the mesh and solve the fluid flow equations. On the other hand, the multiple reference frame or MRF model is a steady state approximation technique where the rotating and stationary part of the domain are divided into separate zones. Each zone is assigned its unrotating or stationary reference frame. This interaction between these zones is handled through source terms added to the momentum equations. The MRF model is computationally efficient but less accurate for cases with large interactions between the rotating and stationary zones. Mesh motion. The mesh motion model in ANSYS Fluent is particularly useful when you're dealing with problems that involve moving boundaries. It allows you to simulate fluid flow in a domain where the shape and size of the fluid region change with time. Multiple reference frame model. The MRF model is an approach used to simulate rotating machinery such as fans, pumps, and turbines in ANSYS Fluent. It assumes that there is a steady state relative motion between cell zones. Steady state simulations. The MRF model is especially useful for steady state simulations of rotating machinery. It simplifies these simulations by treating the motion as a steady state condition in a rotating reference frame. Simplicity and speed. The MRF model simplifies the simulation of rotating parts, making it faster and less computationally intensive compared to transient simulations. User-defined functions, or UDFs. The mesh motion model allows users to define custom functions for the motion of boundaries, providing greater flexibility in simulating complex movements. It's important to note that the choice between the mesh motion and MRF models depends on the specific requirements of your simulation. The mesh motion model is better suited for transient simulations with moving boundaries, while the MRF model is ideal for steady state simulations of rotating machinery. Let's enter the ANSYS Workbench software. Okay, ANSYS Fluent is a comprehensive software suite for computational fluid dynamics. It includes several tools such as Design Modeler, Space Claim, ANSYS Discovery, ANSYS Meshing, and Fluent Meshing. Here, by dragging the geometry and right clicking on it, you can see the Discovery geometry, Space Claim, and also Design Modeler. The software offers advanced geometry modeling capabilities that allow users to create, modify, and manage 3D models with precision. ANSYS Meshing and Fluent Meshing, which are here respectively, mesh. This is the ANSYS Meshing, and just under the Fluent, we have Fluent with Fluent Meshing. ANSYS Meshing and Fluent Meshing are renowned for producing high-quality mesh using advanced algorithms which enables professionals to simulate complex fluid flow problems with confidence. Okay, here I drag the Fluent, right-click, and edit. Okay, our project is 3D, and also I want to start a parallel solution. By clicking on the start, after a few moments, the ANSYS Fluent software will be loaded. Okay, first I want to import the project solved by going to the File, Import, and Case. The location of my file is here, the Bulb Turbine, Case and Data, and that's it. Are you ready to explore a vast array of mission options that will leave you amazed? Our software offers you multiple options to choose from, each tailored to meet your simulation needs and elevate your user experience. But that's not all. We provide you with advanced mesh quality checking tools that are nothing short of impressive. Okay, now the case file is imported successfully. You can check your mesh file by clicking on the check, and now it's okay, and also report the quality of the elements used in your mesh file. With these tools, you can gain a complete understanding of your simulation's accuracy and identify potential issues before they become major problems. This gives you the freedom to concentrate on achieving the best results for your project without worrying about the accuracy of your simulations. With our top-notch machine options and quality checking tools, you're sure to experience the ultimate simulation software experience. Also here, there are some tools for displaying the geometry and mesh file. So, here I click on the display mesh, and here you can see in the surfaces tab all the boundary conditions available in the project. And here you can see that under the options, the faces is selected. This is the wall, moving zone, boundary. Both with the wall stationary zone, outlet, and inlet with the blue color, and also the interior or planes defined. Okay, also we can enable the edge, and now we can see the elements created for the solution, and as you can see its type is polyhedra. You can enter the tetrahedra mesh file and change the type of your elements from tetra to polyhedra by just clicking on this option, make polyhedra. ANSYS Fluent is a widely recognized software package that offers a diverse range of versatile models to address a wide variety of physical phenomena. The software boasts an impressive suite of turbulence models. Here, if you double click on the models, you can see the total models available in the software. Turbulence models including Reynolds average, Navier-Stokes or RANS, large eddy simulations or LES, and also discrete numerical simulation, which is called DNS. Multi-phase flow simulations are enabled through the software's Eulerian, Lagrangian, and volume of fluid models, here as you can see. Furthermore, ANSYS Fluent incorporates heat transfer models including conduction, convection, and radiation to provide a comprehensive solution for computational fluid dynamics simulations. The software also offers various combustion models such as finite rate, eddy dissipation, partially premixed, and premixed to aid combustion simulations. Additionally, ANSYS Fluent provides species transport and reaction models for chemical species simulations and various spatial models like acoustic, porous media, and discrete phase models. ANSYS Fluent's impressive array of features and functionalities makes it a comprehensive and reliable tool for CFD simulations suitable for use in a variety of academic and industrial settings. Okay, now I close the models, and by going to the cell zone conditions, here you can see that we have two different zones. One is rotationary and the next one is a stationary zone. You can hit the zone type, and here we understand that their type is fluid. Okay, here we can double click on the moving zone, and here you can see that for this project the frame motion option is selected. In this window, the frame motion is enabled, and here in the reference frame tab you can see the total bunch of options for this method. You have to specify the rotation axis origin, the speed of the rotating zone, its direction, axis direction, And also you can specify the translational velocity if you have any in your simulation. Also, by enabling the mesh motion option, the mesh motion tab will be enabled. Here the options are same, but the methods are different. Discussing the pressure velocity coupling schemes that ANSYS Fluent offers brings me great pleasure. By double clicking on methods, you can see the different pressure velocity coupling schemes or other different schemes used for the simulation. ANSYS Fluent provides a variety of powerful schemes for steady state calculations. The simple algorithm is an excellent choice, while the simple C scheme offers faster conversions. The coupled scheme is perfect for high-speed compressible flows, and the piezo scheme is ideal for transient simulations. ANSYS Fluent schemes each have their unique strength, providing a broad range of solutions for your simulation requirements. Then we could initialize our solution, in which we have two options, hybrid and standard. The standard initialization method initializes the flow field by setting flow variables to user specified constant values throughout the computational domain. This method is often used when you have a good estimate of the flow field. On the other hand, the hybrid initialization method initializes the flow field by interpolating values from the boundary conditions. This method is particularly useful when you do not have a good estimate of the flow field. It can provide a better starting point for the solver, especially for complex flows, leading to faster convergence. And finally, we have the calculation, the run calculation section. Here, you can hit the calculate after specifying the number of iterations. ANSYS Fluent's iterative mode is a crucial a process that solves complex problems step by step. It's useful for nonlinear problems, continuously refining the solution for better accuracy and control. Upon completion of simulation, Fluent provides a variety of options for analyzing and visualizing the results. Contour plots here. If we read the data of the solved project by clicking OK, contour plots, vector plots, and path lines can be generated to aid in comprehending fluid flow patterns. Okay, the data file is read, and here you can see the contours, vectors, pathlines, and particle tracks of the solution. Additionally, Fluent enables the creation of animation which are useful presenting and understanding transient behavior. Here I want to display one of the contours, and this is the static pressure in these planes defined. This is the erosion rate on the moving zone. And here you can find the velocity magnitude. Furthermore, it offers a quantitative post-processing tools that include calculation of derived quantities, report definitions, and monitors. Here in the report section, you can find these options fluxes, forces, projected area, surface integrals, and also volume integrals. These tools allow users to extract specific data of interest, such as forces on a body, average temperature in a region, or flow rate through a boundary. Fluent's post processing capabilities are highly customizable, enabling users to tailor the output to their specific needs. Overall, ANSYS Fluent's post processing capabilities are essential in interpreting the results of CFD simulations, enabling users to gain insights into their simulations and make informed design decisions. Remember, the best way to learn about these capabilities is to use the software and explore its features. Okay, if you have displayed a contour, vector, or path line, you can click on the save picture option, and using it you can save a high quality picture from the graphical view. Here I have extracted some results from the solution. Okay, that's it, and I hope that you have enjoyed this training video.